Capacitors connected in parallel. So when we want to represent capacitors in a circuit, we use a circuit symbol that looks like a parallel plate capacitor here, two parallel plates. So that's the representation in a circuit diagram. Now we want to know what is the equivalent capacitance when we have two or more capacitors connected in an electrical circuit. We can have a series connection or parallel connection, and we can substitute an equivalent capacitance for the combination of capacitors. So in this video, we're going to consider the parallel configuration where we have the capacitor with capacitance C1 storing charge Q1 connected in parallel to another capacitor capacitance C2 storing charge Q2, and they're both connected in parallel to a battery with battery voltage delta V. Okay, so you can see that this dictates that the potential difference between the terminals of the battery must be equal to the battery voltage. So in parallel configuration, the capacitors have the same potential difference between their plates. So this condition gives us the potential difference delta V1 on capacitor 1 is equal to potential difference delta V2 on capacitor 2, which is equal to delta V, which is the battery voltage. All right. And if you look at the total charge stored in this configuration, the total charge stored will be the sum of the two charges, Q1 and Q2. The individual charges stored in capacitor 1 and capacitor 2. So what is our aim? We want to replace this combination of two capacitors with a single equivalent capacitor, such that the equivalent capacitance will be equal to total charge Q divided by delta V. Okay, so if we look at the charge equation, the total charge Q is equivalent capacitance times delta V. The charge stored on capacitor 1 is Q1, which is C1 delta V1, so that is Q1. And then we have charge stored on capacitor 2, C2 delta V2, which is Q2. Now we know that these voltages delta V, delta V1, and delta V2 are the same. So they cancel out, giving us an equivalent capacitance C equivalent C1 plus C2. Okay, so let's put this in a box. The equivalent capacitance is C1 plus C2. So if we generalize this to more than two capacitors connected in parallel, what would be the equivalent capacitance? Equivalent capacitance would be equal to sum over I Ci for parallel combination. So when we put these capacitors in parallel connection, the equivalent capacitance is sum of the individual capacitances. The equivalent capacitance of the parallel configuration is the algebraic sum of the individual capacitances, and therefore is greater than any of the capacitances. So by placing these capacitors in parallel configuration, we basically make sure that we have a larger equivalent capacitance. So in summary, we talked about the circuit symbol for capacitor, which looks like a parallel plate capacitor in a circuit diagram. And when we have a connection of capacitors in series or parallel, we can talk about an equivalent capacitance. In the case of parallel configuration, we have the same voltage between the terminals of the capacitor plates, and the total charge stored will be the sum of the charges stored by the individual capacitors. So this gives us using the equivalent capacitance is total charge divided by delta V. The equivalent capacitance equals to C1 plus C2 or sum over ICI for the parallel combination. And finally, we find that the equivalent capacitance will be greater than any of the capacitances, so the capacitances will add up.